Use the definition of a derivative to find the equation of the line tangent to the curve f of x equals 3 over x at x equals 2. The first thing we need to do is use the definition of a derivative to get the slope for the tangent function. So what's that? That's your instantaneous rate of change formula, or the limit as h approaches 0 of f of x plus h minus f of x over h. So I am going to use that with this equation right here. So I'm going to start by applying the definition of a derivative to this function. So I have the limit as h approaches 0 of 3 over x plus h minus 3 over x all over h. Now this is a complex fraction, so I'm going to fraction bus to get things out of the denominator. I'm going to multiply the top by the quantity x plus h, and since I can't just multiply the numerator, I'm also going to multiply by the denominator with an x times the quantity x plus h, because this is a 1. In doing so, I get the limit as h approaches 0. Now when I multiply 3 over x plus h times this, the x plus h on the denominator will cancel with this one on the numerator, so I'm just left with the 3x. I have a subtraction sign. When I multiply 3 over x times this, I have an x on the denominator and an x on the numerator, so I'm just left with 3 times the quantity x plus h. And this is all going to be over this multiplied together. H times x times the quantity x plus h. I'm going to do some simplifying here. I need to remember that this is a minus sign, and I'm going to distribute to both terms. So I have 3x minus 3x minus 3h. A lot of students will forget the minus right here. And I have my denominator. That hasn't changed. Now I'm going to do some simplifying. 3x minus 3x is 0. So I have negative 3h over hx, x plus h. Now I'm going to do some simplifying. H divided by h is 1. So I'm left with negative 3x times x plus h. And now I'm going to go ahead and I'm going to apply the limit where h approaches 0, because there's no more simplifying I can do. So I'm going to go ahead and put a 0 in here. So I'm left with negative 3 over x times x, which is negative 3 over x squared. This is the derivative, and the notation I use for the derivative is f prime of x. So this is the slope function. If I go back to the original problem, I'm trying to find the equation of the line tangent to this curve at x equals 2. So to get the slope of that function, I'm going to plug 2 in for x. So this right here is going to become a 2. So I have negative 3 over 2 squared, which is negative 3/4. So this is the slope for the tangent line. One way we could think about lines is in their graphing form. So I like to think about lines like this. Y equals some slope times the quantity x minus h plus k, where hk is any point on the line. The reason I like to do this is because we were given an x value for a point on the line. We were given 2. So all I need to do is figure out that corresponding y value, where this is h and this is k. So how am I going to find that corresponding y value? I'm going to plug this into the original equation. The original equation was 3 over x. So to get this, original function is 3 over x. I'm going to do 3 over 2 because this is 2. So the equation for the tangent line in this case is y equals my slope, negative 3/4, times the quantity x minus the h value, 2, That was the x value given in the problem, plus 3/2. One more thing. If you wanted to check your work, you could graph your original equation and your tangent line function, and you'll see that the tangent line just grazes the function. So I know I did this correct. Thanks, Desmos.